My name is Jake Crum. I'm the State Event Supervisor for Wi-Fi Lab in Pennsylvania. I'm here today to walk you through how to run Wi-Fi Lab's experiment here with all of the equipment that you'll be needing. With me here today is Jacob Bianchi. Jacob was the event supervisor for the North Pocono Invitational for Wi-Fi Lab. He is going to be assisting me with the camera and filling in anything I miss. So the first thing that you need to do is the morning of the event, you're going to do impound. We're doing it all here in the hallway with our device, but you would probably do this in a location close to your testing site. The teams will come in with their devices and you will have these checklists hopefully already filled out with all the team names, but if you don't, the morning of, you can have someone quickly write them in with the team names and team numbers. When the teams arrive, you'll mark off that they have been the device has been impounded and that it is impounded in a box labeled with the team name and team number. You then are going to go through the construction parameters with the team during the morning. This is important that this gets done in the morning so that way there are no time delays. So the team will bring one pre-constructed antenna. The device will fit in a 15 by 15 centimeter box. It'll include the SMA male connector. It does not contain any commercial parts or magnets. The device is entirely passive and contains no batteries or external power supplies. And the device is designed to operate in such a way that it will not damage the backplane or the SMA-F connector. So what I've done is I've got a box that is 15 by 15 centimeters. I also usually carry a ruler with me just to double check if I need to, but I have some samples here. This is an antenna. It fits in the box. It has a SMA connector on it. Here is a different one. You'll notice it does not fit in the box, but I can put it in there in any direction, so it does go in that orientation. This is a quick way to check and make sure everything is going to fit. If it is close, if something doesn't happen, I usually check it with the ruler just to make sure. You'll notice that it does have an SMA connector on it, and that it will attach itself directly into the back plane. Jacob, have I missed anything there?
No, I think you got everything.
Okay, wonderful. So at this point, I would mark true, the device meets all the construction parameters, and then we will do the other parts of this when the team arrives for the testing. You can, if you would like, in the morning, do the chart scores. Depending on the number of people you have with you, you could check them in the morning. If it's just one or two people running the event, it's very hard to do that during the period. You can do that by having the teams go through this process. And look in the handout that came with this video. That will provide some additional information on how to grade these chart scores and the point breakdown. Our device is set up with the backplane. You're going to have pretty much the same device. The state is building a second device that we hope to make reach every regional. There is a router attached to the back of the tripod that is then connected to the wall with a power cord. There is, and this is just attached here with some wire ties. It stays on perfectly fine. I've isolated this additional adapter with an SMA that does not has an insulator on it. That way nothing can be said to be coming out of that particular port. Over here we have the one that is going to connect directly into our SMA connector. As you'll see here, I have the backplane. I also have a multimeter with me that here Jacob has it, and we're just going to check that it has no conductivity, and so it's just made out of some wood, and so Jacob is just going to validate that as well. We're going to make them out of the same material, so all is good. Now, the morning of the competition, you're doing all the checking, you're getting all this set up. You notice I didn't mention this. We have a tape measure large tape measure running the length of the room. This is going to help out with some things as well. And so what we are probably going to want to do is tape that. I don't have it taped down, and potentially mark the front of this so that it is directly over top of the tape measure. That way it gives us an exact measurement all the way through the experiment throughout the day. We have that common line that we're able to validate our information on. So that every team has the same point. So what's going to happen in the morning is you're going to come in and you're going to grab your 3.1 monopole. That is just a paper clip that's 3.1 centimeters in length. You're going to stick it into your connector, making sure that the router is on. So we're going to come back to the computer. We have that 3.1 centimeter monopole out there in the SMA female, and right now we're using a router right now. It says Scioli. It's right here, but we could use a different name. I'm going to try to name the router you have for Scioli as well, and you'll notice that the RSI values in the software are going to be 49 or 50, and so we're going to watch that for about 10 seconds and get an average of that value. Throughout the day, you probably want to check and make sure that's still hovering at that point, because we did have an experience at one invitational where the wires in the back of this did get damaged, and all of a sudden teams were getting bad results. It's really important to make sure that we have connections on all of the ports, the SMA male to SMA female down in here, the RP SMA to the SMA that is right here, making sure that everything is connected. That reverse polarity is tricky here, because if you aren't careful, you could be connecting the wrong port. So making sure that the ports match when you're hooking it up is important. So again, we just have that 3.1 monopole in there, and down on the computer we had the reading of about 50.
Just make sure when you take the threshold that you're 3 meters away from the back plane.
Right, correct. 3 meters out. And we're doing this, we have the computer sitting right here. We can look straight down 3 meters. We're being consistent in that measure with the front of the cart and the computer right here. If you have a computer that has a monitor in the back, this is a tablet, you may want to measure from the back. That way you're consistent all the way through your trials. So at this point, the team would then come in. You would have already done, so you did all of this before they've arrived. You do it once in the morning, and then again double checking throughout the day to make sure everything is okay. But the team will come in. You've already done the checklist, so now you're going to have them come in and take their antenna. The antenna that we have here is that they brought in and are going to use is this one. And so Jacob's going to go down there and pretend he's the team, and here we go. We're going to go down, and we're going to he's going to connect it in. In general, I'm going to stay back at the computer throughout this to keep things moving along. When he starts this, I would start a stopwatch. He has 5 minutes for this entire process to occur. So he's down there making the connection. And again, he has 5 minutes to do this. Okay, he's connected, or his antenna. And so now he has to step at least 5 feet away, and he is going to ask the question,
did I connect?
Did I connect? And my response can only be yes or no. And my response is going to be based on whether or not this value here is less than the threshold value of 50. So when I say less, this is negative 77, so I want to be negative 48, 47, 46. Right now, I would answer, no, you did not connect. So Jacob could go back down and manipulate his antenna. And this is his attempt.
Step 5 feet away. Did I connect?
No. So he stepped away. This is, as you could see, and I'm going to say this out loud for this video, it's close. I would not say that. My answer to Jacob would be no, it did not connect. And so he would have to then make a decision if he's going to go down and modify his position, make sure it connected, or say, I've done with that trial. If he did not connect, as he did not connect here, he could then say, I would like you to move to a different position. He got to choose his position initially. We just did it right here at 3, but we should have asked him right in the beginning what position you want to start at. You don't necessarily have to start it at 3. So we're going to move forward, assuming that he says, I want to go forward. We come forward to they have to be half meter increments. So we come forward to the 1 meter mark. And you'll see here, we have, he'll ask the question now.
Did I connect?
And we say, yes, you did connect. And at this point, we fill out the sheet with the distance in centimeters. So we'd use 100 centimeters. We would say connection successful, and we would record the average, which would be, as you can see, 46 on the RSSI scale over 10 seconds. And as we're looking at that, since the first trial he did not connect, we'd actually mark that as false. So connection 1 would have been false, connection 2 would have been true. And then again, we'd mark the device distance. Then he would have an opportunity once he's connected to move backwards. So if you do not connect at first, you can move forward. If you do connect, you can move backwards. He would choose his initial position. So let's say he decides to go back to the 2 meter mark. Again, 2 meters on our cart. We come in and he would ask the question.
Did I connect?
Yes, you connected, and we would record again the third trial. Again, if you have an extra person, you can have them check the charts at this point. If not, you could do that in the morning. The construction parameters, he did stay 5 feet away during the trial, and modifications to his antenna were not made. He just changed the positioning of it throughout the trial itself. So we have completed this sheet. While this is going on, there are students taking the 30 minutes of the testing, and when the testing is done, you will fill out the written score, and you will mark that there was no violations, and the team is not disqualified by marking a false here, and then enter this whole thing into the Sci Olympiad system in the order that it is. Again, we have a tape measure down on the floor to go as far back as 25 meters. And so throughout this, teams can say, I want to start off at 10 meters or 15 meters. And then if that doesn't work, they can move forward. And if it does work, they can move backwards. We're maxing out at 25 meters, although your venue may not have that space, but we're aiming to try to give that teams about 25 meters of space to run their antennas. As always, if you have any questions, you can reach out to me. My email address is jcroom, jcroom, @pascioli.org. Thank you to Jacob for participating and helping us out. And if you have any questions, again, reach out. Thank you. Have a great day.